everybody. Glad to see you all here. We've got the final session now. We've got two speakers. We've got Jesus first, and then we're going to have Charlie second. As you'll be used to by now, they'll speak for 15 minutes each, and the questions will come at the end of both sessions. So you need to hang on to your questions for Jesus until after the end of Charlie's talk. I don't think we need any further instructions at the moment. Just to say particular welcome to Jesus, because he's the only person not from the Environmental Change Institute who's speaking in this theme. So it's really nice to have a bit more diversity and to hear what he's got to say.
Thank you very much. Hello, everyone. Thank you. It's a pleasure to be here today. I am Jesus Lizana. I am an architect, postdoctoral researcher here in Oxford, working in the Energy and Power Group. And in this presentation, I will show the advances of my Marie Curie project on resilient cooling to mitigate the impact of climate change in cities. A project inside the framework of the Future Cooling program of the Oxford School. And first, I would like to start talking where I come from, because I am from Seville, Spain, a lovely place with amazing food and a fantastic weather, but with last summer reaching more than 45 degrees. So I think that we never saw it. And this is because the way that we understand cooling is changing. Global warming is increasing temperatures globally, and heat events will occur more often and last longer. It's expected that the energy demand for cooling will grow by more than triple by 2050. Even in the UK, it's expected that more than 75% of households will start air conditioning in their houses by the end of the century. So to face this challenge, we need to start thinking about adaptation and not only about mitigation, in order to increase the heat resiliency capacity of our cities. What is heat resiliency? We can define heat resiliency as the ability of buildings and the system to continue functioning as intended in the face of heat stress imposed by the climate change. And in this case, we can find well-oriented policies focusing on energy efficiency and the net zero carbon pathway. But here we are not considering any adaptation pathway. Even most of the time, we are creating some barriers or trade-offs to promote this adaptation. So in this presentation, I will show the different steps that we should to promote in current building regulation and building design in order to improve this adaptation pathway. And they are related to heat dissipation, heat modulation, and solar and heat prevention in the built environment. Let's start one by one. Heat dissipation means the way in which we can reject heat from the indoor environment, from inside to outside. And this is something that we can do by the building surface, by ventilation, or by air infiltration. And right now, current policies are focusing on energy, assuming that in all buildings we have ventilation, we have heating, ventilation, and air conditioning system. And from the energy point of view, when we evaluate these solutions to reduce the infiltration, improve the insulation of the building, we are decreasing the energy demand, in this case for cooling, which is fair. However, when we evaluate the same solutions from the point of view of discomforts, in cases where we don't have air conditioning, we can see as the same solutions are increasing the discomfort hours. Discomfort hours meaning the percentage of time in which our building is having a temperature above a temperature threshold, for example, above 27 degrees. So promoting insulation infiltration and not promoting ventilation, well, we are increasing the overheating on our building by up to 5%. Of course, here ventilation is an option that we can promote to solve this problem. But then we find this other problem, the urban heat accident. And this is related to the higher temperatures that we find in some areas inside the city in comparison with the rural surrounding areas. And this is an example of London last summer, where we can see as at daytime, the temperature perturbation is minimal, below 1, 2 degrees. But as soon as we arrive at night, we can find up to 4, even 5 degrees of temperature difference between some areas in the city and outside. So in this figure, we show a well-designed building, well-balanced from the point of view of indoor temperature and outdoor temperature. With current policies promoting energy efficient buildings and not addressing ventilation, we are overheating our building by up to 5%. And with the problem of the urban heat island, where we cannot cool down nor cities in some areas, we are making all buildings more overheated. And this problem is even worse in warmer cities, for example, in the city of Seville, where I come from. Here you see a real-time mapping in which we are working. We see as soon as we arrive at night, we can see the different areas of our city where this temperature difference is much higher, even higher than 6 and 7 degrees. This is something that we are working right now in order to, in a tool that we can apply, we can use to map whatever city in the world in order to identify these vulnerable areas, in order to support the decision making. The next question will be, okay, how we can increase the heat resiliency capacity of our cities, what we can do. And to answer this question, we have to go to the fundamentals, ventilation and the urban temperature. And right now, building regulations, we are focusing in ventilation for heating system. And in this case, we are limiting our ventilation to the minimal ventilation requirements because ventilation increases the heating demand of our buildings. We are defining mechanical ventilation system or hybrid ventilation system to address this issue. And we have forgotten a large portfolio of solutions to promote ventilation, which can be driven by wind, by solar, or by the stack effect, in which we can increase the heat dissipation potential of our building. And solutions that are not new. Solutions that we can learn from the ancient architecture or vernacular architecture. In this case, the wind catchers of Iran, the ancient Persian way to cool down in your environment, capturing prevailing winds to introduce them inside the buildings. This is one study we compare the average ventilation rate during a whole summer season, comparing a single side ventilation, another house with cross ventilation, and another house with an inner courtyard, promoting heat dissipation by cross ventilation and by the stack effect. And we use the CO2-based decay method to measure the average ventilation rate during the complete summer season. So here we saw in this data distribution values, we saw all the values of the ventilation rate during this complete summer season. And we can see as promoting an appropriate building design, we can increase the heat dissipation potential of our building by up to double. Then we need to identify the way to reduce the urban temperature. And here we need to start thinking in an urban planning less car-centric. The solution is simple. We need to modify the land surface, promoting natural-based solutions or artificial solutions in order to implement shades, evaporative cooling, and solar reflection. And from the point of view of waste heat, we need to be able to find alternatives for heat rejection in transport and building sector. And a successful case is the case of the city of Barcelona with the superblocks model, where they are thinking beyond the car-centric urban planning model to a pedestrian-centric urban planning model, limiting the traffic to the edges of this superblocks model and promoting these strategies related to the modification of the land surface and the waste heat, and promoting even better public transport sectors, to promote this city configuration. Then the second powerful strategy is heat modulation. And this means the use of the building thermal mass to increase even more the potential of heat dissipation. So here we use the building thermal mass to absorb heat gains and to reject them at night when we have this free cooling. And in this case, we did this study in which we evaluated how we can increase the potential of heat modulation even more, implementing phase change materials in order to increase the thermal and electric capacity of our building. And we evaluated the implementation of this material to be able to increase the thermal and electric capacity of our building as a cool battery, being able to store the cool that we have at night for passive cooling during daytime, absorbing all these heat gains. And we were able to reduce the peak temperature by up to 2 degrees and reduce the discomfort hours by up to 75%, combining heat dissipation and heat modulation. Finally, the last best alternative is solar protection. And this is really important in extremely hot countries such as India or Pakistan, where we can find that indoor environment is more than 50% of the time in discomfort. And this is one study that we did in which we compared the synergies and trade-offs between different alternatives to improve the passive performance of the building with regard to cooling. So in this figure, we have the comparison of all solutions with regard to energy savings in cases where we have air conditioning and with regard to discomfort hours. In those cases where we don't have air conditioning and we are evaluating only the percentage above temperature threshold. So here we can see as the second best alternative after ventilation is solar protection on roofs and setting devices in windows. We are able to mitigate discomfort hours by up to 7%, and in cases where we have air conditioning, reduce energy demand by up to 15%. And here again, we see these trade-offs related to insulation or infiltration when we are not promoting ventilation well in the building design. And here again, we have a large portfolio of solutions. This is not something new. We can reduce the solar gains in the opaque surfaces, promoting ventilated roofs or ventilated walls, and implementing reflective materials. And from the point of view of openings, it's the same. Solutions are in the market, so this is not something new. And again, it's something that we can learn from ancient architecture, because the root of the wild villages in Spain is not to promote tourists, it's to be protected from the sun. And the two most important things that I would like to transmit today is that we can implement all these cool criteria, considering in building design, heating and cooling as a whole. And this is one example that we did for the Solar Decalogue competition. This passive house, this climate responsive house, in which we were able to design the inner courtyard in the house to be able to promote ventilation, promote heat dissipation, to be protected from the sun. And in winter, we were able to use the same concept in order to absorb solar gains as a greenhouse, in order to reduce heating needs. And the last element, the most important things I would like to transmit today is that all these cool strategies require a long-term plan. Next summer, we will find some heat events, and the fastest and the easiest response is to buy an air conditioner the day after. We need to start thinking that to implement all these cool strategies, we need to start thinking right now, step by step, because they require time and effort. And it's only then when we need to start thinking in the implementation of the best available technology for cooling. And here we have additional alternatives that we can implement in building regulation and building design in the implementation of these solutions, in order to reduce the size of the system, reduce even more the cooling needs, and mitigate even more the environmental impact. Because comfort is not only temperature, and because the environmental impact of cooling is not only in the operational phase. But this is something that you only will know if you start following our updates in our social media profiles. Thank you very much.
Thanks very much. Architects always have the best pictures, and you've proved that yet again. Although, I don't know, Charlie, maybe you've got something up your sleeve. Okay, so thanks, Charlie.
Yeah, so I'm going to talk about. Oh, am I going the wrong way? Oh, there we go. Yes, so I'm going to talk about digitalization. And I was listening to Jesus talking, thinking, wow, there's like no connection whatsoever. But actually, you very nicely talked about the sort of engineering and design stage to get the buildings and the fabrics right. And then this piece is about, well, what do you then do? What can you then do once you've got the homes that you're living in? So according to IEA, International Energy Agency, buildings is going to be is the end use sector to be most transformed by digitalization. And this is, you see these smart building controls, smart heating, smart lighting, these smart demand response. These are the sorts of things that are starting to appear in the domestic sector with the potentials that they represent to help manage and reduce energy demands and emissions. So here are some sort of app icons of some of the technologies we're talking about. So we've got on the right, smart lighting, smart heating in the middle, and then disaggregated load analysis that increasingly now you can can do from smart meter data. But also there are, I think, other ways in which digitalization is shaping domestic life. The top row of icons are essentially about ways of substituting digital activity for physical activity. So teleworking, which you're all probably sick of by now, having been doing a lot of it for the last 2 years, but those two green icons represent different ways of online food retail, which can substitute for lots of physical trips to the shops and help reduce emissions. But where it obviously gets kind of really interesting in this context, we've been talking about this today, is along the bottom, where you have different ways in which digital tech is, well, either essential or enabling of ways to integrate kind of aspects of our domestic life, whether it's how we charge our electric vehicles, or when we use electricity, to connect those up to the system, to help the system work more effectively, particularly with lots of renewables. So in an earlier study last year, we looked at some of, let me just toggle back and forwards between these two slides, you can see what's changing. That middle smart heating app is becoming a little graph where sort of a range of estimates from the literature about the energy and carbon savings from smart heating systems in various different trials. And if you look at the evidence across some of these other innovations, you see, I mean, a lot of uncertainty depending on the study context, but a sort of general picture where there's certainly opportunities for these digital applications to help reduce energy and emissions. But when you're trying to work out the connection between digital services and energy and emissions, it's a complex picture because you have a bunch of direct impacts in terms of, so imagine your smart heating system, there's energy required to make the little kit, there's energy required to run it, and there's energy required to get rid of it. So those little boxes are colored red because they can make energy go up. So that's like a potentially bad effect. From the use side, in using that heating, you can have efficiency effects. So smart heating, I mean, some trials show that you can reduce gas demand by 7 or 8% just by having a kind of learning system, which avoids heating being on when no one's at home. So that's a beneficial effect. So that's green, energy can go down. Substitution effects is kind of less relevant, I think, for smart heating. But when you think of other services like online retail, you might be substituting for driving to the shops, but you might be then doing lots more retail because it's frictionless and easy. And then direct rebound effects are when you end up using more of that service because it's become cheaper or easier to use. So your smart heating system allows you to turn your heating on when you're away from home because you want to keep your pets warm, for example. And then where it gets really tricky to think about the energy and emissions impact is when you're looking at the systemic effects. So is the time or money or effort you're saving because of the digital technology meaning that you're doing a lot more of something else, which is energy intensive? Or are the sort of efficiencies or social changes in your domestic life causing aggregate growth in the economy or some other form of transformational change, which might be making energy go up or down? So hence these bottom ones have this sort of plus minus complexity effect, which often aren't included when we're looking at energy impacts of digitalization. And so, you know, when you think about the sorts of apps which I was talking about at the beginning, the picture gets quite complex in trying to create a nice line of causality between introduction of the digital service and a sort of definitive estimate of what impact they have on energy and emissions. So that's the sort of the empirical picture, if you like, so far, and then some of the challenges around quantification. When you look at scenario studies which look forward, they tend to assume that digitalization has a beneficial or enabling role. So this is a global energy demand scenario that I was involved with. It's sort of a global analogy to the UK positive energy future study that Nick Eyre was talking about this morning. So I went back to this study and looked at all the sorts of measures and strategies which we were assuming from now to 2050 with respect to thermal comfort in homes. So these were the sort of main measures: low carbon heat and cooling technologies, stringent efficiency standards, and then a dramatic increase in the retrofit rates. They affect energy demand either by reducing activity, by shifting the structure of demand, or improving its intensity, it's improving its efficiency. And then in the right-hand columns is a simple sort of traffic light coding saying, well, are these measures dependent on, enabled by, or really independent of digitalization as a sort of transformative force? And you can see that I mean, simplistically, some of the low carbon heat technologies are certainly enabled by digitalization in terms of the control functionalities. Retrofit rates can also be enabled by digitalization with greater use of data to work out where retrofit could be most effective or efficient. But the kind of really core one around improving efficiency standards is really a kind of secular trend that needs to be accelerated, but isn't necessarily digital dependent. And then a whole bunch of additional measures, and actually many of these we've heard about this morning, earlier on in different talks from today's panel, with perhaps the first one, which is where we see floor area converging on about 30 meters squared per capita in the global north, with a rise in the global south to that level. That's really a function of sort of increased urbanization, not dependent on digitalization. But these other ones where you have more sort of smart heating and cooling systems, demand response we've heard about, and time of use pricing. Tina was talking about this Energiesprung model of standardized retrofit solutions, which is also enabled by digitalization and so on. So if you look kind of overall at this picture, you see focused on homes and heating and cooling in particular, the digitalization has a key role or an enabling role for much of the story in the future about low energy demand. And this is a Sankey diagram from a UK scenario study by National Grid. So this is one of their future energy scenarios. Those not familiar with Sankey diagrams, on the left, essentially you have all the energy resources being extracted from nature, and then the energy flows which lead all the way to the right, showing where they end up. Now this is a scenario, this is representing in 2050. Essentially the yellow is all electricity, and the light blue is all hydrogen. So if you look at homes, which is this bit, it's really fully electrified energy services in homes with a little bit of hydrogen and a little bit of biofuel by 2050. And the important thing is that in this scenario, if you look at the assumptions behind this scenario study from National Grid, here are some of the assumptions they make. So 4/5 of UK homes smart charge their EVs, and over half of that proportion actively provide storage and flexibility services back to the grid. So that's the sort of imagine. So I'm going to come back to this issue of agency and control. So sort of frame that in terms of where control and agency around domestic services lies. Around a third of UK homes are actively managing their heat demand, and roughly the same number have got heat pump systems which can essentially arbitrage between hydrogen and electricity. So sort of increasing technological sophistication, but also quite a distinct role for end users in a domestic context. And this is an example of how scenario studies looking forward can be quite bullish or optimistic about both technological and user assumptions. But when it comes to the specifics of how they imagine agency and users, they tend to be quite coarse. They make quite coarse assumptions. So this is a nice little diagram from a recent study by colleagues at the University of Sussex as part of the CREDS Centre, who took 8 different scenario studies represented in these blobs and characterized them on these spectrums. So the top one shows how did these scenario studies frame the sort of business models delivering digitalization into homes. On the left is it sort of big, controlled by big tech companies, and on the right you've got this more sort of digital commons, public ownership spectrum. And just so you're aware, that red cross on the right is the global low energy demand study that I talked about a moment ago. And then on the bottom, you've got the spectrum between where does agency lie? Is it essentially fully automated systems with the users, if you like, kind of marginalized? Or is it users with full agency and control on the right-hand side? And again, you sort of see this spread in how scenarios capture this, but generally in quite a coarse and simplifying way. So the last thing I wanted to say is to sort of go back from, so gone from this journey from sort of the digital opportunities through the empirical evidence about their energy and carbon impacts, through to these scenario studies that make kind of optimistic assumptions for the future. And the point I'm trying to make is I think where agency and control lies will prove to be critical. So to bring it back to some empirical work, this was from a study from a few years ago that a colleague, Tom Hargreaves, and I were involved in a field trial of some smart home technology, smart heating systems and smart home systems. And we found that learning and control was critical for explaining whether these technologies successfully get domesticated. So domestication is this idea that you can adopt a technology, you can install a smart heating system, but then the real fun begins, or the interest begins, to see whether that then becomes a part of your domestic life. Does it get adapted and appropriated and assimilated into domestic life, or does it get rejected for some reason? So we found three very different types of control. The first one we called artifactual control. So this is the control of a device or a piece of hardware. And in this little sketch with users, the smart home technologies and domestic life, the dark arrows represent the sort of trying out, experimenting process. So this is describing how essentially users get to play around with how these smart home techs can help them in their domestic life. And then the blue arrows are the sort of feedback, the learning and experiential feedback. So in this case, we try out, we experiment, we play, and then we learn whether it actually helps these smart home technologies help us in domestic life. The next kind of control is perceptual. This is actually about whether we feel in control or feel out of control. So here you can see the dark arrows represent the process of users trying stuff out to see whether it helps them feel more in control of the complexities of their domestic situation. And then the experiences then shape whether they feel in or out of control. And we had some nice interview quotes of people who described feeling more out of control because they now had technologies to help them be more in control. So a sort of odd perverse effect. And then finally, what we call relational control, which is about the process of smart households with smart technologies, learning how the technology can help them manage different domestic activities or manage relationships between different household members. And again, the feedback, the learning process then is about relational control. Does this help or hinder in household life? Now, the crucial point here is that the connections between these types of control helped us to understand whether these digital technologies would be successfully domesticated, that's the top bit, or rejected, that's the bottom bit. So let me just walk you through a couple of examples. If you follow this feedback loop by starting along the bottom, you had households, and this is actual household data from this smart home field trial. You had households who were learning how to use the devices, finding out about their functionality, feeling in control as a result of that understanding that was growing, which was giving them more ability to do useful things in terms of their domestic life, which then feeds back along the top, gives them an increased impetus to carry on that experimentation process, confidence and trust that it's actually a benefit to them, and so on in this positive feedback loop. And so over the course of the 1.5-year trial, we saw smart home technologies, these smart heat systems and other smart home systems get more and more embedded into the routines and rhythms of those households with the energy management benefits, which the empirical data I showed earlier can promise. Conversely, you have stories of interaction between these types of control where you struggle to know or struggle to learn how to use the devices, maybe the hardware is poorly installed. We found cases where the use of the technologies was very much dominated by whoever the tech-savvy household member was, which caused disruptions to household relationships. These this poor relational control fed back to household members feeling really out of control as a result of all this control, which then undermines the sort of use case and so on. And this, in some cases, led to the technologies being rejected wholesale. So some sort of very kind of in-depth household level stories about how control is so important to whether the variety of digital applications and services I talked about at the beginning could actually become kind of mainstream parts of domestic life, certainly in the near term. And this is just to finish, is that for me, where it gets really interesting is actually less with the top 2 rows of digital applications, which I think are more about private functional benefits, if you like, that accrue to the households, whether it's through cost savings or whatever, but actually get very interesting in the bottom row, all these different digital applications for connecting homes or electric vehicles at home into networks and systems. Where will control and agency lie? Will we kind of move towards much greater automation with agencies sort of up in the cloud or at the system operator level, or will we move towards very distributed forms of agency that might compromise overall system efficiency, but might be more comfortable for the households? So with that, I'll stop. Thank you.
No, twice ready, we can get a question that works with both of these presentations, but we can start with individual questions. David.
Okay, so I've got a question to Charlie, particularly talks about the bottom row and the impact around these large-scale digitization services. How well do you think we actually understand the offsetting that actually happens? We talk about using these services to lower our individual energy consumption and impact, but isn't there a danger essentially we're just offsetting our own personal use to the energy consumption of the information infrastructure elsewhere? Because we really don't understand that at the moment. So how much consumption the telecoms networks use, data centers and everything else that become an integral part and really should be attributed back to us in terms of our overall consumption.
Yeah, so okay, well, maybe I'm a bit more, maybe I've got more of an optimistic reading of the literature and the data on this than you have, because, so maybe 2 points to make is that, firstly, the energy footprint of data infrastructure as a whole, this is according to a study in Science by Maznet et al. From last year, has been more or less flat, despite almost exponential demands in the kind of compute instances in the data infrastructure, because of both huge efficiency gains and also scale economies in the big server farms and so on. And so they kind of told quite an optimistic story about the ability of efficiency improvements to continue offsetting the scale effects so that overall demand stays relatively flat. And then there's also the other point that generally the data infrastructure side of things, the sort of companies that provide that tend to move very forcibly into renewables, and so have kind of renewable supply contracts on the big data infrastructure. And then the second point I'd make is, and this is reference to an IEA study where they looked at the energy footprint, just by way of example, of watching half an hour of Netflix. And essentially the take home was it's very, 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 very small when you compare it to driving 5 kilometers to a shop. And that's not to trivialize the energy footprint of all the kind of digital data applications that we have, but it's to say that I think it's still relatively quite small in terms of this additional plug load in homes relative to the big things like heating, like hot water, like cooking, and certainly like driving.
So I was just a quick one. So I know Maznet et al. So I think it's the third one of their studies that they've done. And it's not entirely clear that some of their methodologies aren't. Yeah, they've utilised a lot of early data that hasn't been updated. I know Mitten from Imperial looked quite closely at these, and is going to be doing that in his DPhil here in Oxford later. So actually try and update this. But the other one is that the bit that's not included is between the data centres and the person, that nobody has any real clear indication actually of how you attribute that and how much is really being used.
Yeah, fair point. I mean, listen, and you know more about this than I do. There's a nice study actually. So there was a Royal Society kind of process that led to a report in 2020 all about digital technology for the planet. And on the back of that, some folk at Lancaster, Mike Berners-Lee and others at Lancaster, I think, tried to do a bit of a survey of estimates of not just so the energy footprint of digital technology use in homes or in domestic life, the bit in between, and then all the bit in the big data, the data infrastructure upstream. And they took a less optimistic read of the evidence than I was saying earlier with the Maznet study. But I still would say that relative to the big energy users in homes like heating and cooling, it's still, in terms of digitalization in homes, it's still, I would say, net beneficial with lower risk of rebound. But to be borne out in more research.
Radhika.
Thanks, Charlie, that was really interesting. I was wondering about, sort of this idea of control and how you've laid out different types of control and its implications for whether technologies are domesticated or not, but also, how does that control intersect with other things that digitalization provides, right? So, for instance, cost savings, other kinds of co-benefits, what kind of role and where do those, play, have impact in terms of the decisions around domestication and the impact on domestication?
Yeah. So I'm going to give a sort of a kind of a cautious, restrained answer, and then a slightly bolder answer that's less based on evidence. But I think, so on the second part of your question about how does control play out relative to things like these private functional benefits like cost savings and co-benefits, I think we've also heard a lot in previous talks in this session today that there's lots of evidence that decisions we make in a domestic context aren't necessarily driven by cost savings. Of course, we have, like we were talking about in the last session, huge concerns around energy poverty and fuel poverty and incredible cost and price sensitivity. But decisions about should I adopt this smart heating system, I certainly wouldn't frame that primarily as a cost motivated decision. But in other research we've done, you find that those sorts of technologies appeal to the classic sort of technology early adopters who actually tend to be price insensitive rather than motivated by cost saving. So I think it's much more about, certainly some of these digital applications, it's much more to do with sort of technophilia, exploring new opportunities, maybe being able to have certain functionality, like being able to schedule or control aspects of domestic life, rather than this sort of a narrow kind of financial cost saving things. And then my slightly more left field, but bigger picture answer is that and there are people in the room who definitely know more about this than I, but the smart meter rollouts in the UK, which to some extent was sort of putting energy and digital infrastructure in all the homes across the country, was really, really strongly framed around private functional benefit. Like, this will benefit you to X pounds per year in your household through blah, blah, blah. And personally, I mean, I think that was problematic because it depends on so many things that go on in domestic life. But B, I think it was a real shame that essentially what was a national infrastructure project wasn't communicated clearly to households as being with a very different public benefit framing. Like, this is a national infrastructure program which we have to do in order to help us reach this net zero target, which we heard earlier has very, very broad and deep buy-in among the people, among the population. So in other words, that bottom row of apps, which are all about helping homes integrate better with renewable systems, I think if that was clearly communicated with this strong public purpose benefit or message, that where then the control lies on that spectrum between automation and sort of end use control, I think would become a less problematic story. But that's a hypothesis to be tested rather than something I can point to in evidence.
So I was just going to take that question about control and actually put it to Jesus as well, because I was thinking some of the things you were talking about were to do with shading, and some of them were involving active controls by people in the buildings, weren't they? And others were, if you just like to reflect on the issues around controls and how active people have to be.
Yes, I think I was thinking that the implementation of the smart control in all these passive strategies makes a lot of sense. So they are a key point in order to optimize even most the operating condition of the building design in order to reduce or heating or cooling needs. So I think that this is something that I didn't see. It's something that I didn't see in the presentation, or maybe something interesting. But
is it very to the point? Okay.
So Jesus, I was struck by the fact that you, of course, highlighted some very traditional methodologies by which passive temperature control used to be done. Do you think there's also a scope in there about increased utilization of natural materials within the construction industry itself, which of course does then hark back to how we used to build buildings before we got into pre-stressed concrete and everything else?
the problem is the maintenance cost. So I am not that really fan even on natural-based solution for the maintenance cost most of the time. So this is a key point. And we can talk about green roofs, but the cost of the maintenance of the green roof is too high. So here, I think it's more interesting. It's an option, of course, it's an interesting option, but we can apply the same concepts using artificial solutions. So it's a key point. The concept of ventilated roofs, or ventilated facade, finally, the benefits that we can provide to a building with a green roof are the same one. So we are reducing solar gains in a different way.
Marina.
Oh, Jesus. So about passive ventilation and cooling. In the southern Europe, in the heat waves, it was, I think, last year that there was in Athens civil champions that they were going around in houses to motivate and make aware the citizens how to trap cool air in the evenings and how to start understand shading systems and passive cooling. We are in the UK, we don't have these heat waves, but airtight buildings, there is evidence that there is a challenge of overheating. How we can increase the awareness? What is it something that it needs to be integrated in the handover of the property? Is it a service? How we can support, how local authorities can play a role in educating people?
This is something that we were thinking even last month about how to promote, how to engage with these solutions. And here we have, I think that we can define 5 levers for change. This is something that even the Future Cooling Program is working on. On the one hand, we have the governance. I think we should try to promote building regulation thinking in adaptation too. Even in the UK, I think it's projected that 75% of households in the UK will have air conditioning, so something is happening. From the point of view of technological innovance, I think most of the time we are thinking in temperature modification or we are thinking in cooling. Just combining ventilation, air speed, improving, for example, a fan with air conditioning, we can increase the set point temperature of the system. We can reduce the energy demand for cooling a lot by more even than 25%. We also have here the social interaction, how we should promote to understand, to try to engage people with this is another option that we can promote. Then we also have infrastructure design. Here from the governance a key point, but also from the point of view of technicians, mainly how to transmit the skills. That's something that we were talking about before about the heat pumps. And the last one, I think that what was the last one? Sorry. Business models. This is really important because right now with business model we are thinking only in a product as an investment product, and then we don't care about the maintenance, we don't care about the life cycle of the product, so it's gone. And this is the lack of maintenance is one of the main problems in buildings, in heating and cooling system. So here we are able to engage with another different way of business, not business as a product, service-based business and not a product-based business. We were able to sell something, but we can get a fee in order to also be in charge of the maintenance of the different plumbing of the system. This is something that can improve even more these issues in order to mitigate the energy and demand.
Colin, it's your turn.
It's a question for Jesus. If I remember correctly, your graph, one of the graphs towards the end, it suggested effectively the economics of different approaches to heating and cooling buildings. And for example, insulation appeared to have a negative effect on the cooling demand. So I guess because you increase the thermal mass of buildings and so on. So how does this bode for a country like the UK or for Northern and Central European countries where there's a strong emphasis now on insulating homes, but the likelihood of heat waves is increasing very significantly with degrees of factories and plants and so on.
I need to clarify, I am not promoting not insulated buildings. So we need to insulate, but we need to insulate well. So my concern is we are insulated thinking only in heat in the month and in winter season. And we need to insulate and also define a most appropriate way to dissipate heat at summer. So we need to insulate, modify, increasing the insulation of the walls, modifying the windows, but also thinking how we can promote a better ventilation system. So the key point here is the ventilation. Because right now we are thinking only the mechanical or electric ventilation system that we have for heating in order to maintain the minimum ventilation requirement to ensure an appropriate quality, but we are not thinking in another way of ventilation. So my concern is how we should try to modify this building criteria, this building design criteria in the building stock.
I just had a bolt-on question. Did you say earlier that that 75% of UK homes would have air conditioning under certain scenario assumptions?
By the end of the century, yes.
Oh, by two, okay. Because I was remembering, I think in Radicke, your heat maps earlier didn't have much of an effect in the UK, if I remember, under 2 degrees C, but maybe they were to 2050.
They're till 2050,
Okay.
yeah. And I think it is warmer in those two, it's just less compared to some of the other areas, and they were very small.
Yeah.
Who's your question for, Nick?
Mainly for Charlie.
Okay, that's fine.
I'd like to. So, it's clear that digitisation is critical to the energy transition, but we're living in a world where people still don't know how to operate their thermostats, correctly, despite that technology being kind of commonplace for the last 30 years. So, my question is, what are the sort of skills and capabilities that groups in society are going to need to be able to get the best out of these digital technologies and control systems? And is there a risk, I suppose, that some groups will be left behind because they're just less technically savvy and don't have the skills to operate these things in the way that they were designed?
Yes, so in answer to your last question, yes, absolutely. There is a risk that the digital divide will marginalise people from, if you take my kind of opportunity framing of these digital applications, will be marginalised from those opportunities. And the digital divide, falls particularly along fault lines of age, but also, other sort of socio-economic characteristics. I mean, very, 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 very roughly on average across regions in the UK, about 1 in 10 people don't have sort of basic digital skills. So by which I mean sending emails, accessing the internet, and so on. And that's not a kind of a sort of a skills problem. Gavin was talking earlier about the trades, and obviously we might think about skills at the educational level, but this tends to be older folk who aren't necessarily involved in either of those two demographics. So yes, it's a huge problem to which I don't have any specific solutions other than a generic plea for digital skills empowerment as being a key part of what net zero transition means. On the first bit of your question about folk not knowing how to use standards like programmable thermostats, if you like, or they just come home and turn the heating on and then they go to bed and turn the heating off. This is where the sort of smart systems get quite interesting, because you've got very limited capacity to give agency to your programmable thermostat, but you certainly have capacity to give agency to your smart learning thermostat, who can kind of do the programming for you, learning your routines, making sure temperature and so on and so on. And so actually that raises quite an interesting question about whether this new wave of digital applications can help circumvent some of those basic sort of skills and capabilities that have been a barrier in domestic heating. I don't actually have empirical data to point to where I can sort of confirm or deny that hypothesis, but it's a hypothesis in response to the question.
Ted.
This is a full-on question on the perception of control. Does it affect simply the retention of the technology or the uptake of new technologies? I figured, like you talked about retention, so I'm not sure whether it affects both or.
Yeah, good question. So in that particular study, it was about retention. So the study was we essentially installed some smart heating systems and in some other households, some smart home systems that had sort of heating as well as security and entertainment sort of functionality. And the domestication process sees that were unsuccessful because of those negative feedback loops led to the technologies being rejected from domestic life. So essentially either not being used or literally being kind of ripped out. We did in a separate study, we were interested in essentially these kind of spillover effects, that if you adopt certain smart technologies, they work for you because of those positive feedback loops in learning and control, that might give you a higher propensity to try out and adopt new digital and smart technologies. And that particular study never actually went anywhere for various reasons, but it's something that actually Emily, who's sitting next to you, and I are going to be looking at in the next few years in a kind of living lab trial in Oxford. So precisely that question.
Brilliant. I know we've got more questions, but we've got to move back into the plenary session in 2 or 3 minutes. I'm afraid we'll have to close it there. So thanks again to our two presenters.
There was no negative feedback. No, it's like positive that I have. Yeah, I really.
Young architects
Yeah.
We also have a slide, I think,
because that was a really, so I was thinking, there was a lot of discussion about actually how you build stuff in the starting point. And this was one of my, I suppose, one of my points with Gavin earlier. But yeah, it was like, well, okay, you've got buildings, we need to upskill our architects, which in some ways are our surveyors and everything else around these sort of questions. Not just, does it look nice, but also does it look nice and does it, is it?
It's something similar what we were discussing about wind files. So it's rather transparent.
Well, yeah, so Sarah, so that's one of the things we're doing with Sarah, and it's actually saying, okay, if you put the width files where you want now, that's great, but by the time we have 2050,
Let's go for it. Do you like it?
Yeah, it's really good. Yeah. And I really like how
teleworking, and now 2 years later, we'll talk about gas turbines. So, before I get skewered on. Hiya. Yeah, cool. Well, actually, do you know what? Because are we trying to go back?
Yeah, I
to the
think we have to
plenary
go
now?
back.
We're all regathering in the plenary. Are you going to stick around, and then can you ask me after the plenary? Well, because Tina and I have to be, we have to be on stage and give a thing, and I think we're late. I'm not trying to duck your question, but stay around and ask me after the plenary. Yeah, over the tea. Yeah.
We think it's so much about the same on the way there.
Yes. I need to get going to pick up little ones.
Yeah, this one.
So I'll keep an eye.
Just keep an eye, I don't know. And then what I do is I just